Hey guys, here's your guys' lecture on lecture notes on graphing polynomial functions. So first warm up, you guys, is to find the zeros of each one. So first, learning goal, students will be able to graph polynomial functions. So the first part is, can you guys identify your zeros? Well, remember, to find your guys' zeros, it's basically what value of x would make both of these 0? So for this one, you guys, if x was equals to 2, this whole thing would become 0. For this one, if x was equals to negative 3, this whole thing would become 0. So x equals 2 and x equals negative 3 would be our zeros for that function. For this function, if x was 5, if x was 6, and if x was negative 4, all of those values of x's would make that whole function become 0. And for 3, x equals 0. To make this 0, x would have to 8, and for that one, x would have to equals to negative 3. So again, if you substitute in these values in for x, you guys, then eventually that whole equation will become 0. So multiplicities, after factoring the equation for polynomial function f, if the same factor x minus r occurs k times, we call r a 0 with multiplicity k. So I think we can agree with this one that 5 is a 0. X equals 5 is a 0. Because if this is a 5, you guys, isn't 5 minus 5 0? So 5 is a 0, but how many zeros are located at that 5? 2. This degree, you guys, lets you know how many zeros are at that specific location. Which makes sense because if you guys split this up like this, for this one, x equals 5 and x equals 5. So look, there's 2 zeros at x is equals to 5. For this one, what 0 would that be? Well, x would have to equals to negative 4, and it has a multiplicity of 3, based off the degree. So if the multiplicity of a 0 is an even number, the graph will touch the x-axis. If the multiplicity of a 0 is an odd number, the graph will cross the x-axis. So at certain multiplicities, there is a correlation to how it affects the graph. So for example, if you guys had a multiplicity of 1, the graph is going to cross at that 0. So in your notes, write down the word cross, you guys, okay? If you have a multiplicity at 2, it's going to bounce off this 0 right there. If you guys have a multiplicity of 3, this is where it's going to slide at that 0. So it kind of makes this relatively flat line at the x-axis. And if it's a multiplicity of 4, you guys, it will also bounce. It will bounce off of that x-axis. And if it's 5, you guys, it's going to slide. If it's 6, you guys, it's going to bounce, and so on. So basically, if it's an odd multiplicity besides 1, it's going to slide. If it's an even multiplicity, then it's going to bounce. 1 is the only one where the graph is going to cross at that 0. But you guys will see, once we start graphing, you guys will see how we apply these things. So, strategies for graphing polynomial functions. Find your x-intercepts, mark all zeros on the x-axis, determine the end behavior, use the end behavior on the leftmost and the rightmost x-axis, determine the multiplicity. For each x-intercept, use touch or cross to fill in the graph. To find the y-intercept, compute f of 0. So, first, this is not standard form, everybody. This is factored form. So first, let's write down a definition or something that will be helpful. So when you guys have factored form, in order to find the highest degree of factored form, To find the highest degree, you add each you add each power, I'm trying to figure this out. You add the powers of each degree, of each factor. Oh my gosh, I cannot talk. So to find the highest degree, you guys, you add the powers of each factor. Now, to find your guys' leading coefficient, you multiply the coefficients of each factor. Okay, and that will enable you guys to find your guys' degree and coefficients for factored form, which all of these are in. So, to find the degree, again, you guys have to add the powers of each factor. So here's one factor, you guys. What's the degree? It's 2. So 2. What's the power of this factor? X plus 3, the degree is 2, or the power. So add 2. And what's the power of this one, you guys? It's to the power of 1. So this will give you guys your guys' highest degree. Okay? Now let's look at your leading coefficient. To find the leading coefficient of factored form, you guys gotta multiply the coefficients of each factor together. So what's the coefficient here? It's 3. What's the coefficient for this one, you guys? It is 1. That is the coefficient from the x, so times 1. What's the coefficient here, you guys? It is 1. So 3 times 1 times 1, you guys, is 3. So that's our leading coefficient. Okay, now let's find your end behaviors. So the leading coefficient is positive. So the leading coefficient is positive. And your guys' degree, it's odd. So a positive odd, you guys, that goes down and then up. Y-intercept, you guys set x equals to 0. So plug in 0 for your guys' into your function. And if you guys do plug in 0, you're going to get 3 times 0 times 3 squared times negative 4. But all of this is getting multiplied by 0, you guys, which is just 0. So y-intercept is 0, 0. So now let's find your guys' zeros. So you set all of these equal to 0 and you guys solve. So if 3x squared equals 0, you guys, if you were to solve that out, x has to be 0 in order to make this whole thing 0. Multiplicity, look at the degree. The degree of that factor, you guys, is 2, so multiplicity of 2. What's our next factor? It's x plus 3 squared. If you set that equals to 0, you guys, x has to equals 2. What would make this whole thing be 0? If x was equals to negative 3. So multiplicity of 2. And our next factor, x minus 4, you guys, set that equals to 0. What value of x would make this whole thing 0? It would be a if x was equals to 4. Because if x is equal to 4, you guys, 4 minus 4 is 0. And 4, it had a degree of 1, or power of 1. So multiplicity of 1. Now, for multiplicity of 2, you guys, remember, back to up here, this is where a bounce occurs. So it's going to bounce right here. So I'm going to represent that as b. Multiplicity of 2, it's going to bounce. What happens at a multiplicity of 1? Well, if you guys look up here, it's going to cross at that specific 0. So it's going to cross right there. Okay, so now we're all ready to go to graph. So put your guys' end behaviors down and then up. Graph your guys' y-intercept in zeros. So y-intercept 0, 0. What's our other zeros? So we got a 0 at 0. X equals -3. We're gonna plot that. X equals 4. We're gonna plot that. So now let us graph. So when we're graphing this, everybody, we are approaching the 0 x equals -3. At x equals -3, it was multiplicity of 2, which means it bounces. So it's gonna bounce off of that x-axis, okay? Now the next 0 we're approaching is x equals 0. At x is equal to 0, everybody, it's gonna bounce again, because that's a multiplicity of 2. So in terms of curves, you guys, your curves could honestly be whatever length you want it to be. It could be like this short, it could be like this tall, does not matter. You guys are just producing a sketch for us, okay? And then the next 0 you guys were approaching is x equals 4, and at x equals 4, it crossed because that's a multiplicity of 1. So you guys just cross right through it, and there is a sketch for that, okay? So make sure you guys do your 1 through 5. And now let's take a look at our next example. So for this one, let's get our degrees. So that's a degree of 1. So add all your guys' factors degrees. 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4. This will give us our highest degree. So it's 10. What's the leading coefficient? You multiply all the coefficients together. -2 times 1 times 1 times 1. Which is -2. So our leading coefficient, you guys, is going to be -2. So, and behavior. For the leading coefficient, it was negative. And for the degree, it was even. Negative even and behavior, guys, is down, down. And when you guys solve for the x-intercept, you set x equals to 0. But as you guys can see, when you guys plug in 0 and for these x values or x variable, because you are multiplying by 0, 0 times all of this is going to be 0. So y-intercept is 0, 0. Okay, let's find our zeros then, right? So, if you guys set this factor equals to 0, what x value would make this whole thing be 0? That's if x is equals to 0. Don't you guys agree with that? If this was 0, 0 times -2 is 0, right? What's this multiplicity? Look at the power. It is 1. Okay, what would make this 0? Well, if you plug in -5 in for x, you guys, -5 plus 5 is 0. So x equals -5. Multiplicity, look at the power. Power is 2. Next, what would make this 0? If x was equals to 3. Multiplicity, 3. What would make this 0? If x was equals to -2. Multiplicity of 4. So, now we have everything we need to graph. And behavior is down and down. Graph your guys' zeros. So y-intercept first, which is 0, 0. We got a 0 at x equals 0, which we have. X equals -5. X equals 3. And x equals -2. Okay, so now we can graph. So, start from the left. So you guys, we're approaching. We are approaching -5. What happened at -5? Well, at -5, you guys, we forgot. I forgot how. I forgot to write this down. Multiplicity of 1. That's a cross. Multiplicity of 2, you guys. I'm gonna scroll back up. If you guys have a multiplicity of 2, it's going to bounce off the 0. So, bounce. If it's a multiplicity of 3, you guys, it's going to slide. And a multiplicity of 4, it's going to bounce. So, At x equals -5, it's going to bounce off of that x. So you guys bounce off of that 0. At x equals -2, right here, you guys, it's going to bounce. So it's going to bounce off of there. At x is equals to 0, because that's the next one we're approaching, it's going to cross. And then lastly, you guys, it's approaching x equals 3, which is going to slide. So let's talk about a slide, you guys. This is a slide. This is a cross. The slide has a little horizontal line occurring at the specific 0. So when we go to this, you guys, we are going to draw a horizontal line there and then just continue on. That is what you guys call a slide. It cannot be that. What I just drew is a cross. A slide has a little horizontal thing going on exactly at that 0. And then there's your guys' sketch of the graph. So make sure you guys do your guys' scale from 1 through 5. And now we have this. So we're going to go a little bit faster, right? Degrees. So 2, 2, 3. 2 plus 2 plus 3, that is 7. So the highest degree is 7. Coefficient, 3 times 1 times 1. 3 times 1 times 1, which is 3. So the leading coefficient is a positive, and your guys' degree, it is odd. So it's going to be down and then up. Y-intercept, set x equals to 0, you guys. Everywhere you see an x, it is a 0. So if you guys multiply all that out, again, you'll realize that you're going to be multiplying all of these by 0, which is ultimately going to be 0. So 0, 0 is our y-intercept. Now let's get our zeros. What would make this become a 0? What x value if x is equals to 0? Multiplicity, look at the power. It's 2. Okay, right here, what would make that become a 0 if x was equals to -3? Multiplicity of 2. This, what would make that 0 if x was equals to -1? Multiplicity of 3. So if it's multiplicity of 2, that's a bounce. Multiplicity of 3, that's a slide. So we have everything we need in order to graph this, you guys. So down arrow, and then an up arrow, and then graph your guys' zeros. At x equals 0, at x equals -1, at x equals -3. So let's go. Graphing, we are approaching x equals -3, so at x equals -3, you guys, it's a bounce. Guys are going to bounce off of that one. The next 0 we're approaching is -1. It is a slide. So you guys, you're going to draw a horizontal line right at that 0. See? Horizontal line right at that 0. And then lastly, guys, we're approaching x equals 0, so that was a bounce. So we're going to bounce off of that 0, and then it's going to line up perfectly with our end behaviors, okay? And that is your guys' lecture on graphing polynomials. So make sure you guys do your scale of 1 to 5, and make sure you guys do your exit ticket so that you guys are getting all your points, right? Good luck on the homework assignment, you guys, and hopefully this made sense. Good luck. Peace.